go into this, or you're actually pretty comfortable with it? Anything pop up on your mind that you like, I need to think about this for a second? Because this is good. If you guys are saying I'm good, this is a good thing. You're good? Okay, so everybody got like an A or a B right now in the homework? You feeling pretty comfortable? Okay, all right, that's a good thing. All right, so we're gonna do 1.3 today. We've been talking about types of functions. The first type of function that we're gonna focus on, because I gave you some descriptions of what they're gonna look like with the ordered pairs and the XY table and the graphing them and then looking at them from a verbal statement. This particular section just focuses on linear functions. So because it says linear functions, what shape do you think that's gonna look like? Some type of a line. So next slide. Is what the standard, of course we can graph a line, correct? So we know it's going to look like a vertical, it could look like a line. There are several different types of lines, so let me show you from the first bullet, the graph of the function of a line. Here's what the line could look like. There's one line. Here's another line. Here's a different line, and then here's the last line. Alrighty. I'm going to talk about the second bullet as well, because it's going to pertain to the picture that I just drew. So I call the first line I drew an uphill line. Looking from left to right. Looking from left to right. This is an uphill line. Looking from left to right. I call this uphill. This line right here then obviously has to be downhill. I call this one a downhill line. This one is it's a straight line, so is this one. What's the difference between this one and this one? Okay, one's horizontal. This third line is horizontal. And the last line is vertical. All right, so you've got 4 lines on the screen. They're all considered linear functions except one of them. The vertical line is not a function. Why do you think the vertical line is not a function? Because of the vertical line test. It doesn't pass the vertical line test. If I draw one vertical line, it's going to be the same line, right? Yeah. So the vertical line doesn't pass the vertical line test, so it's the only one that's not a function. So if you're looking to see if it's a function, nope, the vertical line is not a function. I'm just going to write that on the board just so you'll know. Yes?
Oh, no, I'm not talking.
Oh, okay, this vertical line is not a function. That's what I'm writing here on the board. That line is not a function. All the other 3 are. Now, when you look at them, they also have something called the slope, which is also called the rate of change. How steep the line is. What we call is how steep the line is, and it's associated with a specific number. Now, question, because this is uphill, the slope could be positive or negative, but because this slope is uphill, what do you think slope is going to be, positive or negative? Positive because it's uphill. Then what's the downhill slope going to be? Negative. So this one's going to be negative. So anytime you take a look at the actual line, you should be able to tell me whether it's going to have a positive slope or a negative slope. Now, what do you think about this line right here? This horizontal line. What kind of slope would it have? It's not uphill, it's not downhill. What kind of slope does it have? 0. So, 0 slope. Now, is that the same thing as no slope at all? 0 is a number. It has to have a slope. The slope is 0. It's kind of like if somebody say, if you have 0 money in the bank, 0 is a number, right? It might not be a whole lot to us, but 0 is a number in the bank account, correct? So, same thing with here. With slope, this slope is 0. This one right here, because it's not a function and because it does not pass the vertical line test, this one has no slope at all. You can't say 0. It has no slope. It doesn't exist. It's undefined. So if a vertical line has no slope, so when you look at it on the computer in your homework, it's going to specifically ask you, it may say no slope, it may say undefined, it does not exist. Any of those words apply to the vertical line. You okay? Okay? Just make sure you remember also, whenever you hear the word slope, the other phrase that you'll hear is called rate of change. So slope and the word rate of change mean the same thing. Okay? Those two phrases mean the same thing. Here's another word that you will see in the future associated with slope also. Marginal profit. This is when you start looking at some of the word problems. You'll hear the phrase marginal profit. It's still asking you for the slope. So if they say, what's the marginal profit, rate of change, all three of those mean the same thing. Okay? Last bullet on this slide says y equals mx plus b. That is called the slope-intercept form of a linear equation. Okay? Y equals mx plus b is the slope-intercept form of a linear equation or linear function, whichever one you want to call it. Okay. Here's an example of one. Alrighty, so let me point out something. The M that you see always represents the slope and it'll always be a number. The B that you see is the Y-intercept and it will always be a number. Okay? M is always going to be characterized by the word slope. I don't know why they chose M, I would have chose S. But again, we didn't create these forms. B is always the Y-intercept. Now, what's an intercept? It's where it touches the Y-axis, touches or crosses. It doesn't have to just touch it. It can cross it. The Y-intercept is that number where your line that you drew or you created touches or crosses the Y-axis. Okay? Your Y-intercept is the point where your line that you drew or that you're going to draw when we start working the problems is where the point where your line touches or crosses the Y-axis. Okay? So, example. Here's my X-axis. Here's my Y-axis. I'm drawing it on the board. And I'm going to draw me a line. Here's my line. All right, 1, 2, 3, 4, and I'm just numbering my y-axis. So if I say, what's my y-intercept? You're gonna tell me the number where it crosses or touches the y-axis. What's the y-intercept? 5. Okay, all righty. So there's your point there. That's 5. Okay. So that's what I want to make sure of. Whenever you see a line, a graph of a line, wherever it touches or crosses the y-axis is always your y-intercept. Now, we call it this letter, this variable b, when you see it written in this form, we're going to call it the letter b. That's just what the mathematicians have called it. So remember, m is slope and b is the y-intercept. They will always be some number. Questions? Okay, here's the next slide. It says again that first bullet is just reminding us that the slope is the rate of change. It's like when you think of, and think of this for a second because it's kind of off the, it'll point back to what we're going to talk about in a minute. If you say you make $3 per hour, is that a rate that you're going to be paid? Is that a rate that you pay? I mean, I know $3 an hour. Okay, let's say $15 per hour. Is that a rate of money that you're being paid? Yes. Yes, it is. So when it says rate of change, that's what it's looking for. So if I was making $3 per hour, the 3 would go here. If I was making $10 an hour, this would be 10. If I was making $25, it would go here. So whatever your rate of change, which is your slope, will always go in the left or in front of or to the left of the x that you see. The slope will always be to the left of the x. But, here's the big but, it has to be written in the y equals mx plus b form. In order for you to tell me what the slope is for any equation, it's got to be written in this format first. If it's not in that format, you can't tell me what the slope is until you put it in that format. Okay, the slope is also called the steepness of the line, which we just said, and we can also describe it as rise over run, and we did say that it's represented by the variable m. All right, so let's look at a couple of slides. All right, here we go. Look at that magenta or pink line, whatever color you want to call it. Is that a positive slope or negative slope? Positive, because it's going uphill or downhill? Uphill. Remember, you got to look from left to right. It's going uphill if you look left to right. All right, so it has a positive slope. What about the next one? Negative slope is going downhill. And of course, this next slide shows you have a horizontal line which has a 0 slope, and you see a vertical line that says no slope at all. So here is the next one. We're going to calculate the slope ourselves. All right, you ready? All right, for this one, we're going to use something called rise over run to calculate the slope. All right, ready? So here is what you see on the board. We're going to do rise over run. All right, so I'm going to point to it on the screen. Here, you're on, this is my line. See this line right here, this diagonal, slightly diagonal line? That's your linear function, or that's your linear equation, that diagonal line that you see on the screen. I want to start, pick one point on that line, and then I want us to get to that point again. You got to get off the line and get back on it. So what I want to be able to do is if I click here and put a point there, so let me kind of draw this on this screen over here a second for you so you can actually see here. If I actually do, actually let me do it this way. Here is my x, y axis. There's my x axis, my y axis. And we drew a line. I'm just drawing the line that they have here. Now, based upon what you see, they just drew some lines here. I'm going to make this line a different color so you can see it. Here's my diagonal line that they have on the screen there. We got boxes here. Alrighty, question. I want to be able to go from one point on the line back on the line again. So here is my first point. Here is my second point. All I want to do is start on one point. I'm going to start on one point, get off the line. I'm going to get off the diagonal line and then get back on it. You understand what I'm saying? All right, well, let me show you. I started with this point. Doesn't matter which point you got to start with, but I'm going to start with this point. I'm going to go to the left or to the right, or I'm going to go up or down. So I'm going to start out doing the rise. So I'm going to go up. How many spaces you think I should go up? 2. I'm going to go 1, 2. How many did I rise? 2. So my rise over here is going to be 2. Alrighty. Then I'm going to run. When you say run, you're always going to be going left or right. When you say rise, you're either going to be going up and down. No, rise always means up. But in this particular case, when we use the phrase rise over run, you're either going to go up or down. Run means go left or right. So I'm going to the right. How many? 1 space to the right. So I ran 1 space to the right. So that's a positive 1. Can I finish it? Can I finish it? What's the final answer? 2. So what is the slope? Remember, this is we said rise over run is equal to the same thing as the slope. So in this particular case, that black line that I just drew on the board, the slope is equal to 2. I want to know if you can see that. Can you see for the line I drew on the board, not what's on the screen up here? On the board, I just drew a line that has a slope of 2, positive 2. Let's see if we can do the one that's on the screen and see if you can be okay with it. Alrighty, so if I look at this point, see where my cursor is? Let me see if I got it where one. Do you see where my cursor is right now? Yes. If I want to go from that point to this point, you got it? You see where I'm trying to go? I want to go from this point to that point. You got to get off the line, then get back on the line. So somebody tell me, if we're going to do rise over run again, which one you want to do first, rise or run? Rise. You want to do the rise first? Okay, so if I'm going to rise, how many should I rise? 1, 2, 3. Okay, so I'm going to rise 3. Alrighty, and then I'm going to go over to the right. How many? 1. Over, and I'm right back on the line. So for the line that's on the screen, what's the slope? 3. Done. Okay. So that's one way to actually calculate or find the slope of a line. You literally just counting spaces. Either you're counting spaces left and right for run, or you're counting spaces up and down for rise. Questions? That's if they give you a what? When would you do this? Only if they give you a graph. They would have to give you a graph. You'd have to only be able to do this if they give you a graph. All righty. What's the next one? Let's look at the next slide. The next slide says, what if I don't give you an actual graph, but I give you some points? I give you some points. The slope is, they're still telling us the slope is still the vertical change, how much you rose up and down, and how much you ran across horizontal changes left and right. Now, where you see those triangles, Y and the triangle with the X, that's called delta Y and delta X. You won't need that because that gets you into some pre-calculus and calculus, and y'all not trying to do that right now, are you? Okay, so ignore your delta Y and your delta. It just means to change the difference in Y and the difference in X, which we wrote right here. So all you need to remember is Y2 minus Y1 over X2 minus X1. You've seen it before, right? Okay. So if you have 2 points, you're going to need to do this slope. Are you going to need to remember this formula for your test? Say yes. Yes, you are. Okay, so now all you need is 2 points. So once we have 2 points, we can actually go ahead and calculate the slope. So here we go. I'm going to give you 2 points. You help me calculate the slope. Here's my first point. 1, 2. My second point is 5, 6. Those are my 2 points. Now let's label them. My first one I'm going to call X1, Y1. My second one I'm going to call X2, Y2. Then I'm just going to plug them in. Alrighty, so let's go ahead and start plugging them in. So based upon that, what's my Y2 value? 6. What's my Y1? 2. All right, what's my X2? 5. And what's my X1? 1. All right, now we just got to do the math. What's 6 minus 2? 4. And what's 5 minus 1? 4. And what's 4 divided by 4? 1. So the slope of, for those 2 points, how many points does it take to draw a straight line? If you want to draw a straight line, how many points do you need? Say 2. You only need 2. All right, so you only need 2 points. So for this straight line that you would have drawn between these 2 points, the slope would be 1. All right, you're good? Okay, question. I heard no. What's the question? No. Okay. Here's the next slide. They give us some points to actually work out. They give us a line. And they say, yes, you know what? We could do the rise over run and count and figure out what the slope is just by counting up and down and left and right. But they're saying, can we also do it using the points that's on the graph? Could we? Absolutely. We could do it that way as well. So they picked 2 points for us to actually do the slope. So they call 2, 3 as X1, Y1, and 3, 6 as X2, Y2. And they just substituted it into the formula. So you end up with 6 minus 3 over, or divided by 3 minus 2, which equals 3 over 1, which simplifies to 3. Question. Does it matter which 2 points I picked from that line? No. You're going to get the same answer. It doesn't matter if you pick the first 2, the last 2, the first and the last one. Any 2 points on the line is going to give you the same exact slope. All righty, your turn. Go. You're just finding the slope using the formula. Anybody else need to sign in while you're doing this? Oh, y'all didn't. You can keep signing on the same page and start a different column. Let me know when you're done. The math should be fairly simple for this particular type of problem, right? Well, you stuck? Okay, all righty. Let's see where we're stuck at. Let me see. I've got -7, 3, and I've got 5, -1. So here's x1, y1, x2, y2. And then I'm just gonna substitute them. So my slope is equal to, here's my formula. Alrighty, so with that said, I'm just gonna plug these numbers in. So I'm gonna have in the place of y2, I'm gonna put a -1. And y1, I'm gonna put a minus, and I'm gonna put a 3. Alright, x2, I'm gonna put a 5. And x1, a -7. Now, did you remember to put those two minus, that should have two minus signs here on the bottom? So those two minuses should turn into a positive. Alrighty, so with that said, I got -1/3, 5 plus 7. Alrighty, so now I end up with what on the top? What's on top? -1 minus 3 is how much? Okay, -4, and 5 plus 7 is? 12. Alrighty. Should I leave my answer like that? No. It's not what? It's not simplified. If you were on a test and you didn't simplify a fraction, I'll take off points for you not simplifying. You might not get the whole problem wrong, but you'll miss 1 or 2 points because you didn't simplify the fraction. How do I simplify this fraction? Reduce it by finding the what? Almost. Greatest common factor. So what's the biggest number that goes into both 4 and 12? 4. So divide both the top and the bottom by 4, which leaves me with what answer? What's my final answer? -1/3. That's the slope. So based upon that, what should you expect that line to look like, since you know the slope is negative? Downhill. Questions about doing this for this one? Yes. Tell me what you're thinking. Oh, well, just this part? Okay, wait, so tell me where to start. We plugged in the numbers, so were you okay with plugging the numbers directly in? Okay, so we got here. Okay, so you were okay with this part right here? Okay, so once we get here, trying to find out that was a 4. Okay, so that's the greatest common factor. How do you find the greatest common factor? You want to find a number, and let me give it to you this way. Here is, this is just a simple way of finding the GCF. We call it the GCF. So this is just a side note for this particular actual lecture. So again, you've got two numbers here, a 4 and a 12. Tell me all the numbers that multiply together to give me 4. And I really want prime numbers. You guys know what prime numbers are? 2, 3, 5, 7, 9, not 9. 2, 3, 5, 7, 11, 13, 17. You can't divide nothing into those numbers except for the number 1. So I want prime numbers. So what times what equals 4?
2.
All right, I got a 2 and a 2. You okay with that? So I know that's 4. Ignore the negative for right now because we're just trying to find out how to find the GCF. All righty. What numbers multiply together to give me 12? 2. A 2 times what else? 6 ain't prime. What else?
3.
A 3. Is that 12?
No.
What else do I need? Another 2. So can I put this in this order? 2 times 2 is?
4.
And 4 times 3 is? These are all, this is called prime factorization. You write all the prime numbers that multiply together to give you the 12 and the 4. If they have a match, drop 1. If this one has a match, drop that one. That one doesn't match with anything, so you got to throw it away. What's left is your GCF. Did you hear what we just did? These two match, so I need to keep 1. These two match, so I need to keep 1. Multiply those two together, and that's how we got the 4. That's your GCF. So you can do this with any set of numbers. So the GCF is equal to 4. It doesn't matter what two numbers you pick, you can do that with it. If there's a number left that you don't have a match with it, you got to throw it away.
Now, how would we graph that one?
So how would you graph the number? So again, all they wanted you to do was find the slope of the line. Tell me whether it's going to be uphill or downhill. And the value of the slope. So the value of the slope was -1/3, and that's all we're going to do with that. It does represent 2 points for a line, though. But that's all you need to do at this point is just tell me if this line is gonna go uphill or downhill and what the value of it is. Alrighty, so here is the next slide. It actually gives you what we just worked out on the board. And it simplified it. It just didn't show you the GCF was 4, but it simplified it for us. Next slide. The Y-intercept. So now based upon what we had on the first board that's up here up top, that B that you see where we said Y equals MX plus B, B is always the Y-intercept. And we said that was the what number? Where it crosses the what? Where it crosses or touches the Y-axis. That's always your B variable, but it'll be a number. Okay? When you say it's the number, let me write it up here. Come back down with this board. If I say, what's the Y-intercept? You have 2 ways to write your answer. You could say 5. For this picture we already have on the board, the Y-intercept is 5. So if they just ask you what's the Y-intercept in the homework, you could just say 5. But, or they could also say, can you write that answer as an ordered pair? How would you write this point right here, that's 5 on the Y-axis as an ordered pair? How you write it as an ordered pair? What comma what? 0, comma 5. So the Y-intercept will always have a what in the front? Always will have a 0 in the front when we say it's a Y-intercept. Your homework could ask for it in ordered pair form or just the number 5. It just depends on what it chooses to ask for. Either one, just make sure you know, read what it says in the parentheses in the blue underneath the answer box. It'll tell you how it wants you to write the answer. Okay? Questions? Alrighty. Next slide wants you to find both the Y-intercept and the X-intercept algebraically. Algebraically means they want you to work it out by hand using algebra. Now, we just figured out what the Y-intercept is, right? It's where it crosses the what? Then what should the X-axis, the X-intercept be? Where the line crosses the X-axis. So you're looking for those 2 points, where your line crosses the X-axis and where it crosses the Y-axis. So we're going to do that algebraically. Now, the easy way to do that, now here's a picture that I'm going to go ahead and walk through. What's the easiest way to find out where it crosses the X and the Y-axis? What's the easiest way? To look at it on the graph. In what tool? What software do we use? Desmo. You just type that equation in Desmo and poof, it'll pop that answer up for you. So let's just go to Desmo so you can see it. So go to Desmos for me, please. Let me find mine. There it is there. Delete what's on the screen. That equation was 4x minus 8y equals 16. Well, I can't see anything on my screen. Do you see something on your screen? What's wrong with my window? It's not right. So here's one of the things I always need to do. If you see a little home button over to the right of your screen, if you have changed your Desmos at any point in time in the past, it'll leave it like you last left it. So if you left it like that, if you hit the home button, it'll put it back in standard form. So if yours was already in standard form, then you already had the line when yours was typed in. So there is the line. Now, can you see the X-intercept and the Y-intercept? Yes. And so if you click on it, it'll tell you what it is. So what's the X-intercept? Okay, if it says order pair, you're going to say 4, 0. If it just says what's the X-intercept, you're just going to say 4. Okay, what's the Y-intercept? 0, -2, or just -2. Now, wasn't that easy? Okay, for test purposes, you won't be using this tool for this. You will have to do it algebraically, which is what I'm getting ready to show you. So just remember, for homework purposes, you can always go put it in Desmos and see what the answer is. And then go back and see if you know how to do it, because on the test, you need to be able to do this manually. So let's figure this out manually. Can I erase any of this here? You guys, are we done with this? Can I erase it? Okay. All right, I'm going to leave that up there. Here we go. We're going to find the X and Y intercept algebraically using the notes on the previous screen. So the notes on the previous screen that we were just in the PowerPoint. Here was the previous screen. This is what it says we're going to do. So we're literally going to do just what it says do. So, to find the x-intercept, and I usually abbreviate x-intercept with x-int, it should say to find. Okay, to find the x-intercept. First step says do what? To find the x-intercept, to find the x, I'm sorry, I'm doing the x-intercept. Bullet number 2. To find the x-intercept, what should I do? Tell me what bullet number 1, the bullet says under find the x-intercept. Okay, so I'm going to plug in a 0 for what?
Y.
Okay, plug in a 0 for y. And then what should I do based upon the notes? Solve for x. That means when it says solve for x, are you sure that means get x by itself? That's exactly what it means. Make sure you get the x by itself. When you say solve for whatever letter, it means get that letter by itself. Alrighty, so here we go. I'm going to replace, and here's my original equation. This is 4x minus 8y equals 16. You said plug in a 0 for y, so now I've got 4x minus 8 times 0 equals 16. Well, what's 8 times 0? 0. Okay, so I've got 4x minus 0 equals 16. All right, what's 4x minus 0? 4x, and that's 4x equals 16. There we go. How did you get x equal 4? Okay, so divide both sides by what? 4. All right, so divide both sides by 4. So x equals 4. Done. Now, I added steps that you don't have to put in. So, for example, I can see that it answers 4. So, if you're skipping steps, like this is an extra step that you didn't need because you know the 0. You didn't need this step either. You could have come all the way down from here and gotten to here without all the extra work. That's fine if you're comfortable with your answer. But usually I try to put those extra steps in because when you get home, you're like, well, how in the world did she get that 4 at the bottom? So that's why I usually add the extra steps in that I know it seems simplistic, but it's helpful sometimes. All right, does that make sense? All right, so what's the x-intercept? 4. How do I write it as an ordered pair again? 4, comma 0. All right, well, let's do the exact same thing for the y-intercept, only this time we're going to plug a 0 in for the, we already did it for the y, we're going to plug a 0 in for the x. Okay. All right, so we're going to find the y-intercept. All righty, so now I've got plug in 0 for the x. So now I've got 4 times 0 equals, not equals, but 4 times 0 minus 8y equals 16. What's 4 times 0? 0. So I've got 0 minus 8y equals 16. All right, what's 0 minus 8y? Negative 8y equals 16. Divide both sides by? Negative 8. So once I divide both sides by negative 8, y equals what? Negative 2. So what's my y-intercept? How do I write it as an ordered pair? 0. All righty. Aren't those the same answers we had in Desmos? Exact same answers. So for test purposes, this is what I would expect to see on your scratch paper. Like I said, you can skip steps if you want to, as long as you know you got the right answer. Skip steps, that's fine. Just make sure you got the right answer, because if you skip a whole bunch of steps and you got the wrong answer, I don't have any place to give you partial credit. So make sure you put the steps you know you have to have. Yes, ma'am. You can use your handheld calculator at all times. You will not be able to use your computer calculator. Does that make sense? Okay. I will tell you on all tests, I'll usually give you 2 problems, maybe 3, that you can use Desmos for, and then I will tell you to close your laptop and you'll finish the rest of the test by hand. So I would not tell you to use, for this type of problem, when we got to this, your laptop will be closed. So as I'm saying, make sure you know how to do this algebraically. All right, questions? Here is, in the next slide, they worked it out for us. Can you see that they skipped the steps, some of the extra steps that I put in? Can you see they skipped them? Perfectly okay for you to do your scratch paper for a test, just like what they did. Okay? All righty. That sounds pretty easy, right? Y'all didn't say anything. Okay, just checking. Okay, so here we go. This slide is still dealing with the slope-intercept form of a linear equation. The slope-intercept form is always what? Y equals mx plus b. Are you going to need to remember what that is? Yes, you are. So always remember y equals mx plus b is the linear form, it's the slope-intercept form of a linear equation. So if you wanted to pick some points, again, they'll give you an equation and you could pick some points to create. So if I give you y equals 3x plus 1, can I plug some numbers in to find out what points lie on that line? Look at the equation I just wrote, y equals 3x plus 1. Could I pick some points to plug in to figure out what points land on that line?
Yes.
Yeah. Can I plug in a 1? Yeah, if I plug in a 1, what's my answer going to be for output? 3 times 1 is how much?
3.
Plus 1?
4.
Ah, so if I put in a 1, I'm going to get a 4. What if I put in a 2? 2 times 3 is?
7.
6 plus 1 is?
7.
All right, what if I plug in a 10? 30 times 10 is 30 plus 1, 31. Okay, so you see what I'm saying? Could I create a line from just some points?
Yes.
Sure you can. So I'm saying if they do give you an equation and you would need to, hey, find some points, you would just plug some numbers in for x and y. That's it. You plug some numbers in for x and generate what your output should be. All right, here's the next slide. All right, your turn to make sure we're on the same track and we understand what y equals mx plus b is. So m is the slope, right? B is the y-intercept. The slope is always the number that sits to the left of the x. The y-intercept is always the number that sits to the right of the x. All right, so now when we say that, does it have to be written in that format for you to tell me what the slope is?
Yes.
Yes, it does. The y got to be by itself on the left. Okay, so what's the slope for the first one?
2.
What's the y-intercept?
1.
All righty. The second one, what is the slope? -1. So you do know that if there's a negative in front of a letter, that there's an invisible 1 right there? You didn't? Okay, so here, anytime that you have a negative, it could be a negative x, p, q, whatever letter of the alphabet, anytime there's a negative in front of a variable, that's really -1x. Got it? Always, if there's a negative in front of any variable, that's a -1. So if I say, what's the slope, you're going to tell me? -1. Okay? Question. All right, third one. What's the slope? 3/2. Did we say the slope couldn't be a fraction? No, we never said that. Can the slope be a decimal? Yes. It could be any of those numbers. It could be a negative, positive number, a decimal, a fraction, any of those types of numbers your slope can be. What's the y-intercept for the second one?
-4.
And what's the y-intercept for the third one?
-2.
Okay, all righty. Questions. Can you graph that line just like it is? In decimals, we could just type it in and know exactly what it's going to look like. Well, first of all, do you know whether they're going to go uphill or downhill? Well, tell me first, the first equation, uphill or downhill? Uphill because? +2. Second one, uphill or downhill? Because? Third one, uphill or downhill? Uphill because? +3/2. It's just positive. Now, in the homework, it's going to say the number that sits in front to the left of the x is always called the coefficient. That's just another mathematical name for the number that sits in front of any letter is called the coefficient. But we just want to remember it's the slope. You got it? It does have its own name, but in this particular case, it's the slope. All righty? So here is the next slide. We just said everything that we're just reconfirming what we just said. All righty. Next slide. Practice. Everything in here relates back to real life, right? Remind me to show you how to graph each of those lines. And actually, let me do that now. Let me show you how to graph at least one of those lines, 2 of those lines, so you'll know how to do it by hand. Yes, you can go to Desmos, but what if you have to do it by hand? So let's do one of those, at least 1 or 2 of them by hand, so you can see the graph of them. All right, ready? Here's my graph. Here's my x-y-axis, x-axis. Here's my y-axis. First equation. I'm going to graph the first equation by hand with no Desmos. Okay? Ready? What's the slope? 2. Whenever you're going to graph a line by hand, you need the slope to be a fraction. Can I turn a whole number into a fraction?
Yes.
How do I do that?
Just add a 1.
Put a 1 underneath it, so always turn it into a fraction if it's not already a fraction. What's the y-intercept?
1.
Okay, well, let's put this y-intercept is 1. All right, step 1, plot the y-intercept first. All righty, so what's the y-intercept again?
1.
So where do I put that point?
On the 1.
On one where?
On the Y.
On the y-axis, okay, all righty, so 1, 2, 3, 4, 5, and I'm just gonna put a 1, plot it on the y-axis. So step 1, plot the y-intercept on the y-axis first. Okay? Step 2 says to take the slope, here's your slope, and use it as a rise over run. So, let me write what I said. Take the slope and do rise over run using the slope that you have. So, what's my rise over run for the slope that I have? 2 over 1. There's your rise over run. And we're going to do just what it says. Is that a positive 2 and a positive 1?
Yes.
Yeah. All righty. So, starting on the point that you already have on the graph, how far should I rise up?
2.
Okay, let's go up to 1, 2. I went up 2 because it's positive, right? Okay, how far or how much should I run?
1.
To the right or to the left?
Right.
To the right because
Positive.
it's positive. So I'm going to run 1 to the right and put a point. Done. Connect the dots. Step 3, connect your dots. Connect the dots. Once I connect the dots, I have a straight line. We just graphed by hand that equation of that line. We just graphed by hand the equation of that line. Can I do that with every equation? Sure. The ones that have fractions as the y-intercept will be a little bit more difficult, so I will give you one that has a fraction as the y-intercept, because you won't be able to put it in properly. All right, so here is the last one. I'm going to graph the last one, and then we'll stop with that. All righty, so now you help me with the last one. Bullet number 3, or equation number 3, it says y equals 3 over 2 times x minus 2. All right, what's the slope? 3 over 2 that I'm going to use as the rise over run, correct? Okay, and what's the y-intercept? Negative 2. All right, what was step 1? Okay, so I'm going to plot the y-intercept first, so I'm just going to draw me some lines here. All right, the y-intercept is negative 2, so come down to negative 1, negative 2. All right, so there's my first point. Step 2 says take the slope and do the rise over run. All righty. Are they both positive numbers, the 3 over 2?
Yes.
Okay, so what should I rise?
3.
Rise up 3. Let me put some more lines up here. 1, 2, 3, 4, 5, 6. All righty. Go 1, 2, 3, 4. Wait.
It should be 3.
Just 3, right? Okay, so 1, 2, 3. All righty. Run how many? 2. Which direction? To the right or to the left?
Right.
To the right. Because it's positive, we're going to run to the right. So here I'm going to go 1, 2. Once you get to 2, put a dot. Now connect your dots. This is how you graph it manually. You can do this all day. Yes, you can type it in decimals and it'll give you a pretty line in a couple of seconds. So now you know how to do it, right? All righty, let's look at our last word problem. Everything in this class relates back to real life, right?
Yes.
All righty, so you're like, how in the world is she gonna relate this back to real life? All righty, what's our step 1 when we're doing a word problem?
Read it.
Let's read the problem. The amount of money, which we're going to call Y, remaining to be paid on a loan of $60,000 for the Escalade you bought, with $16,500 of interest, where Y is 76,500 minus 1,275 times X, where X is the number of monthly payments that have been made. All right, so let me make sure okay, I don't know, how many of y'all have bought a car? Majority. You know somebody bought a car. Okay, you know somebody making payments on a car or a truck or whatever you want to call it. All righty. Do they start out with a certain amount that they owe the bank from the time you drive the vehicle off the lot? Absolutely. So let's kind of look at this for example. I'm using Escalade just because it could be a $60,000 vehicle. All right, so the $60,000, when I say make sure you read and understand, you got to make sure you understand what every word in the word problem means. What's the $60,000? That was the price of the car or price of the Escalade or whatever vehicle you bought. What's the $16,500? Did they let you have the money for free? No, they did not let us have the money for free. So now on top of the $60,000 that the vehicle costs, they're going to charge us another $16,500 just to let you borrow their money. You got it? Okay, so again, when I say understand, you see how you got to kind of think and break it down and make sure you understand every single number and word in the problem. Then they gave us an equation that models what's happening or what they want to happen based upon the word problem. So now they've got Y equals 76,500 minus 1275X. Now, clearly, what does X mean in this word problem? That you paid. You got to say that you already paid. You can't just say the number of monthly payments. It's the number of monthly payments you already paid. Why do I have to designate that? Why do I have to clearly make sure I understand that?
Because you can say monthly payments
And it doesn't tell me enough information.
Yeah.
Right. In terms of why do I need for X to be the number of monthly payments I already paid? So what's Y? Tell me what Y says. Again, we got to make sure we understand the problem. What is Y?
what's left of the remaining to be paid on the loan.
Okay, so let me make sure we understand. You made 5 payments. Do you still owe them some money?
Yeah.
So if I subtract those 5 payments, will that tell me how much money I still owe them? That's the remaining amount of money you still owe the bank. So let's look at this clearly. That equation says you're going to have to pay me $76,500 for the Escalade after you drive it off the lot. Your monthly payments is going to be $1,275 per month. So each time I make a payment, what's going to get subtracted? $1,275 every time you make a payment. Well, guess what this X represents? The number of payments you already made. So if I made 5 payments, it's going to be 5 times $1,275. If I made 10 payments, it's going to be 10 times $1,275. You got what I'm saying? Okay, so that's what we're just trying to make sure we understand everything that you're doing, that we're doing in this problem. Why do we even need to do that? You got to be able to multiply how many payments you made times the $1,275 and subtract that amount from the original amount that you owe the bank. So that's why they wrote that equation like that. So now let me make sure that we're on the same page. Let me erase this. I need to ask you a question. The equation that you have, is it written in Y equals mx plus b form? Hold on before you say something. Hold on. Does it really look like it's written in Y equals mx plus b form? You might say no, but let me ask you a question before you say no. Can I write this like this?
Yes.
Yes, you can. Isn't 3 plus 2 the same thing as 2 plus 3? Okay, so here's what I'm saying to you. Can I rewrite that equation like this, showing, what's it, 76,500. Here's my plus, and I got a negative 1275x. Can I write it like that? Yeah. Based upon what I just wrote, what's the Y-intercept? 76,500. What's my slope?
Negative 1275.
Negative 1275. It's a rate of change. Remember, how much are you reducing your payment, your amount you owe the bank by every month? By 1275, you reducing. That's the rate of change. How much is what you owe them changing by? It's changing by 1275. Question: if you had to graph this, what would it look like?
It would be
That would be down here.
Can I write it like this as well? I'm writing this up here so you can see. Are these two things the same thing?
Yeah.
Yes, they are. This one's written in the proper y equals mx plus b form. Correct? You can always rewrite it so that it makes better sense to you. Now, why do you think they wrote it like they wrote it?
Because they want you to deduct the 1275.
They want you to see that you deducting the amount you paying them every single month. So when you see money that you paying, don't you want to see it reducing the original amount that you owe them? That's why they wrote it like that, so that you see you are subtracting the payments that you made. So what should this graph look like? It's gonna be downhill, don't you? Do you want it to be downhill?
Yes.
Because you do want the payments to go away, don't you?
Right.
All right, where was the Y-intercept at?
76,000.
Okay, so 1, 2, right up here, 76,500, which is what you owe the bank when you drive off the lot with it. So this is owed money, dollars, owed to the bank. That's what's on this y-axis right here. What's on the x-axis?
The months. So 12.
Okay. All right, so first month you made a payment, second month you made a payment, third month you made a payment. How many months can we go out? Well, sometimes they'll let you do how many months now? 8 years worth of payments for a brand new vehicle? All right, so keep going until we get all the way down to, it could be 72 months, right? To pay that off. Now, so first month you made a payment, second made a payment, third you made a payment. Shouldn't this go all the way down like that? That's what that line should look like. The slope was negative, so did you know it was going to be downhill anyway?
Yes.
Yes. So what's the question that we asked? So again, let me make sure we went through. Did we read the problem?
Yes.
Did we go through and try to make sure we understood everything about this problem?
Yes.
Okay. Did we figure out what they gave us? Did we talk about what was given?
Yes.
We had the 60,000. We got the 16,500. We talked about all those numbers, making sure you understood with each one of those numbers. Were you given an equation?
Yes.
Yes, you were. So again, we talked about everything that you were given. Yes.
They just they just want to know where the Y-intercept, which was the 76,500. That's all they are asking for.
We just answering. We just asking for that. That's all they asked. The slope. They said the slope. Did we figure out what the slope is?
Yes.
What's the slope?
Negative.
Negative 1275. And the Y-intercept again was?
So, but when you said it's just going downhill, that's all. That's just what you're telling us. It's just going downhill.
I added that to it.
Oh, okay.
But based upon it said, what is the slope? Not only did we say it's negative 1275, I added to it that it was downhill because we know that because it's negative, it's downhill. But that wasn't the question. They didn't ask us if it was downhill or not. So I added some extra stuff to it. Also, where it says interpret these values, that's where we're adding more explanation to what this word problem is about. By saying, now what does all of this mean? That's where we're back here saying, this is what you owe the bank. This number is going to keep going down by $12.75 every single month. And this one, so I'm adding some additional not interpretation, but just explanation for what this problem wants you to do. We want to be able to take this, and for anything that you make a monthly payment on that you got to pay off, this is what happens. Whether it's a car, a house, a boat, a school loan, whatever it is, are you making monthly payments till you pay it off? This can be applied to any of those. You know what the monthly payment is, don't you? Done. I don't care if it's $30,000 and you're making $500 monthly payments, you can write an equation. So again, if you have something that's $30,000 and your interest is, let's say your interest is gonna be $5,000, alrighty? Here's how much I owe the bank. What's my monthly payment? $500 a month. There's my equation. Question?
I have a question.
Mm-hmm.
Okay, at the bottom it says the constant term is 76,500.
Yes.
So is the Y-Intercept always because?
It is always the constant
I
term.
think that the 1275 would be the constant, because you're always paying that.
Okay, here's what they mean by constant. That's the number that never changes. It's always gonna be 75. It's not gonna change and be like, oh, by the way, we just gonna drop that payment. You don't owe us nothing but $60,000. That number is constant. It is never going to change. The bank does not call you back up and say, we have changed our mind. You don't owe us $76,000. That number is constant, so that's why they're calling it constant. Now, the 1275, although it's not gonna change, it's the rate for what you're paying. You see what I'm saying? It's sitting right next to the X. If it's sitting next to the X, it's gonna be the slope.
I understand, but see, to me,
Mm-hmm.
the 76.5 will change because you're reducing it every month by 1275.
You're reducing the amount you owe. You're not reducing what you originally paid. Right. The amount that you originally borrowed from the bank is always gonna stay the same. What's changing is how much you still owe them. That's what you see what I'm saying? But I got what you're trying to say. Because you're saying, yes, the amount you still owe them is changing, but the original amount never is gonna change. Okay?
Until you pay it off.
Until you pay it off, and then it's zero, and hopefully they won't contact you again, and I have most of them say, okay, you can borrow some more money if you want. You get those little things in the mail where they say, I know you paid this off, but we would like for you to borrow some more money. No. All right, question. Are we okay with this? Okay, so now you have enough information to do what section? 1.3. You have enough information to do section 1.3 in the homework. So that is that. So let me go and make sure I close this out. Let me stop that.